Welcome back. In this video, we'll go over positional parameters. In many cases, scripts or programs require argument values to be provided as inputs. The arguments are the values provided after the script name when running it. For example, if you run apt install nginx, apt is the program name, install is the first argument of the script or of the program, and nginx is the second argument of the script of apt. The name of the script and the arguments are separated by spaces, which by default is known as internal field separator or IFS. There are some predefined parameters, aka positional parameters, that store the arguments of the script. By the way, a parameter is an entity that stores values. It can be a name, a number, or one of the special characters we'll talk about later on. Parameters referenced by a name are called variables. Those referenced by a number are called positional parameters and reflect the arguments given to the script. Parameters referenced by a special symbol are auto-set parameters that have different special meanings and uses. You can think of a variable as a parameter denoted by a name. Now, returning to the script's arguments, they are stored in positional parameters denoted by one or more digits. Take a look here. For example, you might have script.sh and run it like /script.sh and then a series of arguments like filename.txt, directory1, and an IP address. $1 is the first positional parameter or the first argument of the script, and it stores the value filename.txt. $2 is the second positional parameter and stores the value of the second argument of the script, which is directory1. Also, there's $3, the last positional argument, and it stores the last argument of the script, which is the IP address. Note that the positional parameters may be referenced as $, and a digit, or as $, and a digit in curly braces. If there are more arguments, $9 would be the 9th argument. But remember, after $9, the arguments must be enclosed in curly braces. For example, $ curly braces and 10 in between would be the 10th argument. Positional parameters are very useful, so I've created the following script for you to see exactly what the positional parameters mean. This is the script. All these predefined parameters are already available and can be used inside any shell script. I'm running the script first without any arguments. And we notice that $1, $2, $3, and so on are empty because there are no arguments. I've also introduced a special parameter, $0, which stores the name of the script as it was invoked. Let's see what happens if we run it with some arguments. So the name of the script and A, B, C, D, E, F, G, H, I, and so on. And we notice that $1 stores the first argument of the script, $2 the second argument of the script, which is B, $3 the third argument of the script, which is C, and so on. Once again, starting with the 10th argument of the script, it is mandatory to use the notation $ and the 2-digit number in curly braces. Another useful feature is that you can provide a default value to a positional parameter so that if the script is run without the parameter, it doesn't crash. To provide a parameter with a default value, use the following syntax. Write the digit that represents the parameter between curly braces, add a colon after the digit, and then the default value, like this, dash ABC. The default value will be ABC. I'm saving the script and splitting the terminal in two, and I'm running the script in the second terminal. I'm running it without any arguments. And we notice that the first argument, which was $1, had the default value. Let's end this video with a script that uses a positional parameter. I want to create a new script that takes a file as an argument, displays its contents, and then creates a compressed copy of it. So the name of the script will be display and compress.sh. The first line is the shebang. I'm displaying a message which says what the script does. It's always a good idea to tell the user what's happening. So echo displaying the contents of $1. And I'm pausing the execution of the script for 2 seconds so that the user has enough time to read the previous message, sleep 2. Next, I'm displaying the contents of the file, which is the first argument of the script stored in the positional parameter $1. So cat and between double quotes $1. Remember that $1 is predefined and already exists. It doesn't need to be declared and holds the value of the first script's argument. I'm writing an echo for an empty line, and then echo compressing $1. And once again, sleep 2. And I'm running the command that will compress the file. tar-cjvf $1.tar.gz. It will be a gzip archive, and $1, the file that will be compressed. Note that the archive will be created in the directory where the file resides. I'm saving the file, setting the execution permission, and running the script with a file as an argument. For example, block _ip.sh. It's running. It has displayed the message to the user, then the contents of the file, and then it has compressed the file. Now in the current directory, a new file appeared. We see that it worked as we had expected. The contents of the file were displayed at the terminal and the file compressed. Of course, you can call it with any other file in the system as an argument. This time, I'm running it as root because the archive will be created in /etc. So sudo, the name of the script, positional parameters.sh, and a file from /etc. For example, /etc/password. I'm sorry, the name of the script is display and compress. This is the archive. Okay, for the moment, we are done with positional parameters. Up next, we'll apply what we've learned about reading the user input and positional parameters to a real project. See you back in a moment.